logs. What would you think would be the most common base number you would use? Nope. Think of how our number system works. Why 10? Think about it. When you write a number, think this is back in elementary school. This is the what place? That's the ones place. Then you got the tens. Then you got the hundreds. Okay, so that's 10 to the first, 10 to the second, thousands are 10 to the third, etc., etc. So if you're talking our number system, when we change to scientific notation, how do we write scientific notation? Something times 10 to a power. Our entire number system is 10. So yeah, logs base 10 were the most common logs. Okay, and mathematicians are lazy people and they want to write everything as fast and quick as they can. So just like they didn't want to write the 2 on a square root, nobody wants to write the base 10 on that log. So they said, we're not going to write it, just like square roots. If there's nothing there, then it's automatically a 10. And the whole world knows that if there's no base on the log, it's 10. Your calculator, when you press a log, it's going to assume that you're using base 10 unless you tell it otherwise. Now, these calculators do let you type in another base, which is a first. No calculator has done that before. But if you don't type a base on your log in your calculator, it will do a 10 automatically. Which, I guess, by the way, I should point out, it is also right over here. You'll notice, I don't know if you can see it on here, but on your calculators, it's a 10 to the x key. And what's right above it? A log. Why would a log be on a 10 to the x key? Yeah, because the two are inverses, so yeah. So notice when you hit a log, it's going to leave a spot for you to type a base number if you need to, but if you don't, if you just want to skip it, say, let's do log base 10,000. It's going to do a base 10, so therefore the answer is 4, because 10 to the 4th is 10,000. A dot? Yeah, it does have a 4 decimal. Yeah, just means 4. Exactly 4. Yeah, that's all it's doing. Okay. So consequently then, if you see a log with no base on it, you're going to know it's base 10. So you're going to see some problems like this. If I say, what's the log of 100, how are you going to figure out, without a calculator, how are you going to figure out what log of 100 is? Why is it 2? Yeah, 100 is 10 squared, and we know this is really a base 10. So, yep, you're going to get a 2. Okay, what if I ask you for the log of a decimal number, well, like 0.00001? Then what's it going to come out to be? Without your calculators. You are close. Joel said -4. Okay. Count. It's the same thing as move it into scientific notation. How many decimal places do you have to move to get it into scientific notation? 1, 2, 3, 4, 5 loops I made there. So that's actually 10 to the -5. So therefore my answer is what? -5. They both have base 10. So if it's a number bigger than 1, if notice there's 2 zeros, the answer is 2. If there were 5 zeros, the answer would be 5. If you're doing decimals, though, it's going to be all the zeros plus 1 more when you're doing the negatives. But that's common logs. We like common logs. They're handy. They're not near as crucial now because of the fact that your calculators do more for you than they used to, and particularly back on the days of slide rules and stuff like that. You really loved common logs. For us, though, probably the most important log that we use is what's known as a natural log. Natural log. Natural. Nature. What base is it going to have? E. Natural logs are base E logs. Okay. But once again, mathematicians went, we don't have to write that little e all the time. So we can't just write nothing, because common logs are when we write nothing. So they said we need a different symbol for natural logs. We're just going to write different letters. Okay. So, well, they actually took the N and the L of natural log, but they write it in reverse order. It's L-N. Lowercase l, don't capitalize your L's. I don't care if you do a lowercase cursive L, but that's a natural log. Okay, all Spanish and French students.
Yeah, no, Spanish is out.
Yeah, yes, you know this much. Why is it logarithm natural?
Because the verb or the noun comes before, or it comes after you describe it.
Yeah. Yeah. You always put the noun, then you put the descriptive word after it. The adjective comes after the noun. We say pretty girl, they say girl pretty.
Yeah, that's so weird.
Yeah. Yeah. So, since this was all Latin-based languages when this was discovered, it's logarithm natural. So you're going to see ln all the time, and you'll notice you have a natural log key on your calculator. It's the second of your e to the x key. You'll see you have natural log built on there. So if you're down here above your e to the x key, you'll see natural log. So we use that a ton. So if I go control e to the x and I ask it for the natural log, if you ask for the natural log of a number, it's going to just kick some decimal at you. It's got it pre-programmed in there. So it saves a ton of time. So now, let's see if you can figure out, what if I gave you the natural log of e to the 815th power? Anybody with your gut instinct and knowledge of what I just tried to beat into you, tell me what's going to happen. What base is on that log?
It's going to be 850.
I got a vote for 815.
The base is E.
The base is e. So if the base is e on the log and the base is e on the exponent, yeah, Kennedy wins. It's 815. You love to see natural logs and e's put together. They cancel each other out. They're inverses of each other. So you're a happy camper if you see natural logs involved with e's. So I could even go crazy on you, and suppose I gave you the natural log of the cubed root of e.
Maybe 1/3.
How did she get 1/3? Why is it 1? Yes. E to the first power, so that's the fraction 1/3. And then because you have a natural log of an e, they're inverses, they cancel out, you get 1/3. So you love to see e and natural log put together. They take each other out. Ooh, no, I'm not over. Okay, we're okay. All right, so now that we all know the basics, we can finally solve a problem. Yes, we're going to solve equations and we're going to graph. We're going to have time. Graphing's easy if you've done yesterday's.
So, I have a question. Are all the notes not on here? Natural?
Nope, because I didn't get as far as I needed to yesterday. Yeah, I'm going to that's why I'm re-recording, because I'm going to repost. Yeah. I wasn't real happy with yesterday's recording anyhow, so we'll just redo and I'll repost them. Okay, so now you're actually ready to solve equations. When you see an equation with a log in it, okay, and right now, today, you are only doing solving equations when you have one log in the problem. What you do when you have multiple logs in the problem happens Tuesday. But this is what you do when you have one log in a problem. I will say this 50,000 times. If you have a log on one side of the equal sign, to work the problem, you're going to want to change it to exponential form. Change it back to an exponent, take it out of a log. That's another one of those big deal critical things. It's on your journal somewhere too. Okay, So, when I say change it to exponential form, in this case, I mean ask yourself, which number is the base? Base is 5. Which number is the exponent? 4. So 5, if you go back to exponential form, it's saying 5 to the 4th power equals x. So hey, ta-da, you just solved for x. And 5 to the 4th is 625. Okay. You like that kind? That was really nice. Some of them have a little more pizzazz than that. Okay, suppose I give you log base x. This time your variable is the base. You don't know what the base is. Log base x of 64 equals 2. Okay. It's going to be x to the 2nd power equals 64. Okay, then technically what do you have to do to solve it? You have to square root it. Is she correct? Is it going to be plus or minus 8? Yeah. But here's where you have to check your answer. You remember I told you back there that everything attached to a logarithm must be positive? So that means if you're solving for a base, it has to be positive. So would both of those answers work? Yeah, because negative 8 would not make you have a positive base. So you would actually have to throw out negative 8 as an answer. You can't have it. Only positive 8 would be an actual acceptable answer. If you're solving for a base, it's got to be a positive number. Good so far? All right. So you want some challenge in your lives. Okay, what if I gave you log base 2 of negative 8 equals x? 2 would be my base. Uh-huh. You what? Can you do this one? Can you have the log of a negative number? Nope. You can't have negatives with the log. So actually you could have looked at this problem and never started it and gone, this is not possible. It's a no solution instantly because you can't have a negative number with the log. Period. So if you get a negative number with your log, you are done. You get to quit. So we like that one. All right, I'll give you one that's actually fair game here. This is kind of probably the trickiest form I can give you. If I gave you log base 25 of the 4th root of 5. Okay, so the base is 25. The exponent's always what you're equal to. Okay, and then 4th root of 5. Wrote that wrong. Okay. So this is where yesterday's, remember I told you that yesterday's problems were coming back? This is yesterday's problems. You got to make it have a common base before you can solve it. So you must rewrite it to smaller numbers. So 25 would become what? I have to rewrite it as something to a power. 5 to the 2x, because it would be 5 squared. And then I have to rewrite this one with a common base. And how do I write? A 4th root is an exponent. Okay, that was not a real confident 1/4. Yes, no, 1/4? Yes, 1/4. That's right. And then what do you do once you get your bases the same? Yeah, since the bases are equal, then you can say the exponents are equal, and you can solve for x. Okay, now, this is a really sad commentary, but I have a million people miss this simple algebra. I cannot tell you how many people miss this. How do you solve for x? Yes. In my opinion, that's the easiest way. If I have a fraction on the other side. You can, but this is simple math. We shouldn't have to put this in a calculator. Okay. Two choices. My preference, if I'm going to do it, when I see I'm working with a fraction, I times it by half to make it cancel, because then I know I won't screw it up, which gives me x equals an eighth. Now, the other way, somebody said divide it by 2, because normally when you do algebra like that, you divide by 2. That's fine, but you got to realize what you're doing. If I divide by 2, how do you do 1/4 divided by 2? You have to multiply by the reciprocal, dude. So that means I would be flipping over the 2/1, I would be multiplying by 1/2, so it's still an eighth. Or whoever said, I'm actually not sure, I shouldn't teach you that, somebody said cross multiply it. 8x equals 1, so x would equal 1/8. Yes, times by 4 divided by, times it by 4 would make this 8 when you divide it back. Yes, you can solve it that way. Just be careful, it drives me crazy when we miss simple algebra like that. Then I say evil things and shake my head and moan and groan, and my family doesn't like it when I'm grading papers and saying things. Heaven forbid if I would disturb